Now that we've talked about ionic compounds, let's take a quick look at how molecules form. Imagine that the compound HCl was going to form. So here's the dot diagram for hydrogen, and here's the dot diagram for chlorine. Now remember, hydrogen only has just that one electron that you see. So if it was to give away its electron, like all the other members of its group, it would not get a noble gas configuration because it would have no electron at all. So instead of one thing losing an electron and another thing gaining electron, they take these two electrons and share them as a pair between them. And the way we draw that is to connect those dots. So it looks like this, and this is the shared pair of electrons that is the single covalent bond. So that line represents two electrons that are shared between the two atoms. So that's a very simple molecule. Let's take a look at what happens with diatomic oxygen. So here's oxygen with its 6 valence electrons, and here's another oxygen with its 6 valence electrons. So if the same thing happens and the oxygens share these two, I'm going to redraw that here with a line between them to represent the two that they're sharing. But notice that they also still have the two that are on the bottom. So what if those two also pair up? Now since they're shared, I'm going to put those two between them as well. So this time we have two shared pairs of electrons. And we call that a double covalent bond. So in the example of HCl, we have a single covalent bond, and in the example of diatomic oxygen, we have a double covalent bond. And let me show you one more example. So let's take a look at diatomic nitrogen. Nitrogen has 5 valence electrons, so its dot diagram would look like this. And probably you can guess what would happen here. So if nitrogen shares these two, and these two, and these two between them, we would redraw that like this. And here's the unshared electrons that they have. We call those unshared electrons a lone pair. So that's called a lone pair of electrons. Those are the unshared pairs. And then here we have 3 shared pairs of electrons. So that would be a triple covalent bond. And what you should notice in all of these cases is that they do have an octet of electrons because this oxygen is surrounded by these 8 electrons and this oxygen is surrounded by these 8. So they get an octet even though they don't have 16 electrons between them. And same thing here. This nitrogen has these 8 and this nitrogen has these 8. So now that I've shown you how the molecule forms and how we see these covalent bonds in action, let's talk about naming the compounds. So here are 10 prefixes that we use to indicate how many things are in each of these molecules we're going to look at. And the reason we have to use these prefixes when we name covalent compounds is because many times the nonmetals that bond to form these can do it in a variety of ways. And if you take a look at my examples down here, you'll see 3 different combinations of nitrogen and oxygen. And if we called them all nitrogen oxide, that would be awfully confusing about which was which. So we use the prefixes to indicate which is which. So we've got very, very simple rules here, just 2 of them. So we're going to name the first element and replace any subscript it would have with a prefix. So we're going to start with N2O, and the first element is nitrogen, and its subscript is 2. We're going to replace that with the prefix di, so that would be dinitrogen. And then the second rule is name element number 2, so that would be oxygen. replace the subscript with a prefix. It has a 1 that we don't write, so that would be monoxide, because then we change the ending to IDE. So dinitrogen monoxide. So that is this one. Now let's do the next one. There's N2 again, so that's dinitrogen again. Only this time we have O5. So that would be pentaoxide. And a lot of times when there would be two vowels side by side, they eliminate one. So we would say dinitrogen pentoxide. So that would be this one. And then last NO2. So this time just nitrogen. No di on the front. And then the 2 on the oxygen would be dioxide, just like carbon dioxide. So that's this one. Okay, so now let's do it the other direction. This time we're going to do the formula writing rules. So basically we just do the exact same process in reverse. So let's take a look. We have carbon tetraiodide. So rule 1 is to write the symbol for element 1. So carbon is C. And then replace the prefix with a subscript. But it doesn't have a prefix, so no subscript. And then write the symbol for element number 2. So tetraiodide. So that's iodine in there. Replace the prefix, tetra, with a subscript. So tetra means 4, so Ci4. And then diarsenic, so that would be As for arsenic, and there's di, so 2, and then trisulfide, so S3. And last one, selenium, Se, and then hexafluoride, so F6. And that's all there is to it.